Hey guys, let's go to problem 24. I need to evaluate something. And evaluation actually for this one kind of sucks. I mean, it's not something that we want, but I got to try it out though. 24. And so we got 24 out there. Okay, so let's just try to move it right here. So 24, so r cubed and plus I'm adding with 6 times r squared times s. And I'm also adding with 12r times s squared. And that becomes 8s cubed. All right, so we got to think about some, like some Pascal's triangle. We can actually solve this using Pascal's triangle, but before knowing what Pascal's triangles are, like we can actually evaluate by plugging those values are, like plugging these given values. So if, let me erase this, if r equals 2, and s equals 1. All right, so got it. In order to evaluate this, I'm plugging these given values. So we got 2 cubed out there, and I got 6 times what? Like 2 squared times s, which is going to be 1. And I'm multiplying with this 12 times 2, and I'm also multiplying with 1 squared. And we got 8 times 1 cubed. Okay? So if you write it down accordingly, these are 8, and these are 24, and you can check that these are also 24, and these are 8, right? So let's just try to group these first two and the last two. You can check that these are 32, right? These are 32, and we also have another 32 out here. So eventually we get 64. Eventually we get all 64 by evaluating. Now, what if you want to try something else? What if you want to solve this without using this type of, like the substitution? Well, we can actually got to think of something called Pascal's triangle. And let me talk about what Pascal's triangle is. So here we go. So Pascal's triangle. So Pascal's triangle. Usually it starts with 1 and 1, 1 and 1, 2, 1 and 1, 3, 3, 1 and 1, 4, 6 and 4 and 1 and 1, 5 and 10 and 10 and 5 and 1 and so on. We can produce lots of numbers out here. So it looks like some kind of like a triangle. And the rule here is that this little 3 has been adding those 2 numbers that are on top. So 2 plus 1 becomes 3. Well, what about 10? It's going to be 6 plus 4, so that becomes 10. And all the other boundary lines supposed to be consisting of 1s, right? So the first row is actually called the 0th row, and I have not made this, okay? Don't blame me. This is called the 0th row. And the second part is known as the first row. And the third line is known as the second row. All right, so we keep writing all of these. And why do we care about all of these? Because Pascal's triangle, in fact, gives us some kind of coefficients when we multiply binomials by binomials. So for an instance, if I tell you what's going to happen, all right, so here we go. I got a plus b to the power of 0. Well, I get just 1. Now, if I write it a plus b to the power of 1, I get 1 times a plus 1 times b. Okay? And what about a plus b to the power of 2? Well, I can tell you that this is going to be 1 times a squared plus 2ab plus b squared. All right, so here we go. So 1 and 2 and 1, you can see that 1 and 2 and 1, they're actually popping out as the coefficients. What about the third row? You can check that a plus b to the power of 3 will eventually become a cubed plus 3a squared and b, and that will be 3ab squared, and that becomes b cubed, okay? So we get 1, 3, 3, and 1 out there. Now, how do we use this in our example? So let's go back to our example. So how do we use this in our example? Well, come to think about it, that looks like a cubed, and this looks like b cubed. And if you try to see what has happened, if you say r plus 2s cubed, well, you can check that these are 1 times r cubed, 3 times r squared times 2s, okay? So we have those expressions, and we have 3 times r times 2s squared, right? And we also have 2s cubed. All right, so if you expand all of these, that becomes r cubed, and we multiply 3 by 2, indicating that we get 6 times r squared and s, and we have 3 times 4, which is 12 times r and s squared, and we got 8s cubed, just like this. And as you can check from these lists, you can check that these are exactly corresponding to the written ones, right? So I would say instead of substituting all those r and s in the given original form, it would have been better if I knew that's true, and knowing that plugging r into the upper one, or I would say the cube of the binomials, we would have spent less time, right? Would have saved lots of times. So that becomes 2 plus 2 times 1 cubed. And what is this? 4 cubed. We get 64. And that shall be it.